Hello class, we meet again in the second video. Okay, so here we are going to deal with this method where we are going to find a volume of a solid generated by revolving the region bounded by, this is our curve, which is from all this information we should obtain our area, and we are going to rotate it about x-axis. So whenever you see the word about there, it represents your x-axis. So it represents your rotation axis. And here you need to do some correction, which is it will rotate about line x equals to 4, not y equals 1. So please make sure you do the correction on that part. Okay, next we are going to sketch the graph. So in order for us to do that, let us use this whiteboard. Okay, I already put the graph there, which is, this is our main curve. So y equals to square root x. I already draw it in the red color pen here. Y equals to square root of x. And then we have x equals to 4 should be a vertical line, intercept at 4 on x-axis. Y equals to 1 is a green color, horizontal line, which intercept at y equals to 1, which is y should be 1 there. And this is our main region, or our main area. So next we are going to go for our slicing method. So as we know, the rules of slicing method is that slicing method must be perpendicular with the rotation axis. So now where's our rotation? We are going to rotate it about x equals to 4. So x equals to 4 is a blue color line. So we are going to rotate it about this one. So we are going to rotate about x-axis. So here we are going to rotate the region here, or we are going to rotate our slicing part here in a rotation of x equals to 4. So now our slicing part is a vertical one. So this is rotate. So we are going to slice it based on horizontal line. So here, let me draw the slicing part, which is you are supposed to get a horizontal line. Here you can draw the horizontal lines anywhere as long it is within this region. So let's say I want to put it somewhere here. So let me try to make it thick. This is our slicing part. This is our side. So now imagine that we are going to rotate the slice here about the x-axis. So we are going to actually have another object somewhere here for the slicing part. And the distance of the measurement and the length of the slice here must be the same as the image that we want to portray here. So basically we will get the same value somewhere here. So this is our another image of it. So you are going to get a rotation, something like this. Okay, so now it will create or generate a circle, but now the circle is not something like this. The circle is in terms of horizontal plane somewhere here. This is our circle. Now let's assume that this is our circle, although it's not so circle. So let me erase it. Okay, I think I need a space on it, so let me erase all this part. because we already sliced it. Let me draw the circle again. So now let us try to extract the circle. So we have a circle something like this, and for sure at the middle here will be your center, and the radius can be obtained from here to here. This is our radius, r. Okay, as we already know, in order for us to find a volume, it can be integrals from somewhere, value from here, ab, ax, dx, or either we can change into cd, ay, dy. So now we want to determine which formula we are going to use, whether it is in terms of x-axis or y-axis. So in order for us to determine that, okay, now let us see how does the image of the circle look like. If a circle is something like this, we get the image of this one. So basically we are going to use the x. But now since we get the circle something like this, so we are going to use the basically dy. So we can ignore this formula. We can use this formula. So in order to determine the limit here, C and D, C and D here now, because we want to use the dy, so it must come from the value of C and D come from y-axis. If you deal with x-axis here, so basically the value of A and B here is in terms of x-axis. But here now, we are going to use the C and D as our limit, so we need to take it from y-axis. So from y-axis we can already know that the value here is 1 for y, but here we will know the value here is 4 for x. So how about this part? So in order for us to get the value here, we are going to put the value of 4 into the equation here, so which is, it will become a square y equals to square root of 4, which is y equals to positive 2. Get 2 there. So now if we want to calculate for the volume, it will be the integration from it's not 0 to 4 because this is x-axis, it must be 1 to 2. So it will be 1 to 2 for the ay dy. Okay, next we are going to tackle on this issue, which is on how to find the value of ay. So as we know, we get the object of a circle, and circle, the formula is pi r squared. So we are going to deal with the r squared here, which is, we can write our integrals now, become 1 and 2 pi r, because this is in terms of y, we are going to get it as ry to the power of 2. Okay, pi is a constant, so we may take it out 1 and 2. So now it's time for us, we can bring the pi outside. Okay, so now it's time for us to change the value of ry. So r is given by this part, so basically we can say that this is our r, which is, we can get the measurement by calculating this part and this part. Right minus left. Okay, the value of r can be obtained from the right point, which is somewhere here, right point, minus with left. Okay, now let us try to determine what is the value of right and what is the value of left. Okay, right minus left. So here the value of right side represented by x because it lies on this graph. So we can write it as 4 minus with h lies on the graph of a red color, which is it represented by y equals to square root of x. But here we cannot write it as square root of x because we want to create an equation with respect to y. So it cannot be x there. So in order to get the correct answer here, we need to play around with the equation of y equals to square root of x. So let us change the terms. This is y in terms of x. Let us now change into the x in terms of y. Basically, we can bring the power of 2 to the other side, so it becomes square root. Bring to the other side, it becomes power of 2, which is x equals to y squared. So here we can say that the equation here is no longer valid, which is we can change it into alias y equals to sorry, my bad, it's supposed to be equals to x equals to y squared. You can just delete this part. X equals to y squared based on our calculation. So here the right side we are going to take this one, which is it will be y power of 2. Then plug in into this part, which is we are going to get here 4 minus with y power of 2. Okay, now we already set up our equation. So since I don't have enough space there, so let me try to solve it somewhere here. Let's continue somewhere here. So integrate pi is still at the outside part. So 4, if we try to integrate, we are going to get here 4y. Integrate negative y squared, it becomes y cubed over 3. And then you put the value of 2 and 1 there. So here it will be 4, pi is still outside there. So 4 multiplied with 2 minus with 2 cubed over 3 minus with 4 times 1. So 4 times 1, because we are going to replace all the value of y now into 1 minus with 1 cube over 3. Okay, make sure you are going to put a bracket for it. Okay, so you can press your calculator to obtain the last answer for it. Okay, after plugging the value into the calculator, you are supposed to get the final answer is 5 over 3 cube unit, because we try to find the value of our volume. Okay, you can write nicely in our notes, in your notes later. Okay, make sure you draw it nicely. Okay, and we are going to see the next method. We call it as a washer method. This is a disk method, so we have another method to calculate the volume, which is we call it as washer method. So see you in the next video.